Welcome everybody to this month's Pacific Northwest Drought Early Warning System Drought and Climate Outlook webinar. My name is Jason Gerlich and I'm with NOAA's National Integrated Drought Information System. This bi-monthly webinar series is hosted by NOAA's National Weather Service and NIDIS, the USDA Northwest Climate Hub, and the Oregon Climate Change Research Institute. It is designed to provide the Pacific Northwest with timely drought and climate information. Each webinar is tailored to reflect recent current and forecasted conditions and climatic events, observed impacts, and other relevant updates from across the region. The recording and other supporting materials will be posted on drought.gov after the webinar. Today's speakers are Jacob Genuisi with the Washington State Climate Office, providing our climate recap and current conditions. Then we have Henry Pye, providing the seasonal conditions and climate outlook from NOAA's National Weather Service Northwest River Forecast Center. And then Michelle Leroux will be providing the El Niño-Southern Oscillation update with NOAA's National Weather Service Climate Prediction Center. At the end of all three of these presentations, we will have time for some Q&A as well. Before we begin the presentations, we wanted to highlight the partners who make this webinar series possible. The Northwest Climate Hub develops science-based, region-specific information that will assist agricultural and natural resource managers with climate information, decision-making in Idaho, Washington, Oregon, and Alaska. You can find relevant links to the Northwest Climate Hub in the chat. OCRI, the Oregon Climate Change Research Institute, is a network of researchers at Oregon's public universities who work with public and private entities to advance understanding of regional climate and climate adaptation. OCRI is administered by Oregon State University and hosts the Oregon Climate Service, the Office of the State Climatologist of Oregon. NIDIS was established in 2006 by public law with a mandate to provide the best information and resources available to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. NIDIS maintains a national drought early warning system where networks of partners provide information and actions that help communicate and cope with drought. You can stay updated on conditions in your state and local area with using the U.S. Drought Portal, and respective links will be placed into the chat. Now, to help facilitate the early warning system, more precipitation observations are always needed. So we encourage you to join CoCoRaHS, the Community Collaborative Rain, Hail, and Snow Network. CoCoRaHS is a unique nonprofit community-based network of volunteers who work together to measure and map rain, hail, and snow, and then report on these conditions. To become a volunteer or to learn more, you can visit cocorahs.org or contact your state coordinator. Respective links to your state coordinator will be placed into the chat. Now, understanding how drought impacts you and your region is important for drought assessment at the state, regional, and national levels. The National Drought Mitigation Center Condition Monitoring Observer Reports, or CMOR system, is a great way to submit these impacts you are experiencing from too much or too little water. This information becomes accessible to those who assess drought in your state for drought monitoring purposes and is also used for Pacific Northwest water year impacts assessment. What happens in your area, it matters. It matters for our ability to assess drought. Here on the screen, you can see a response in the CMOR system from Baker County, Oregon, articulating some of the reservoir conditions that they're experiencing in their area, given the conditions that we have experienced throughout the winter into the spring season. On April 7th, the Washington State Department of Ecology issued a drought declaration for the entire state, citing near record low snowpack, threatening summer water supplies. This is the fourth year in a row that some parts of Washington will be under a drought declaration, and a formal drought declaration allows for emergency drought relief, utilizing the bulleted points there that you see here on the slide. A link to the formal declaration and information on financial assistance will be placed into the chat box. On April 13th, Idaho Governor Brad Little and the Idaho Department of Water Resources declared a statewide drought emergency for all 44 counties across the state due to record-breaking warmth historic snowpack deficit, and projected water shortages. The last statewide drought emergency declaration for the state of Idaho was in 2001, and a formal drought declaration allows for the respective changes of water rights as articulated here on this slide. Oregon has issued 9 countywide drought declarations due to above normal temperatures, below normal precipitation, stream flows, and snowpack, and drier than normal soil moisture conditions throughout the winter and spring seasons. There are 3 counties currently pending drought declarations: Coos, Wheeler, and Klamath counties. And you can see here on this map from the Oregon Water Resources Department those counties that currently have a drought declaration in place and those counties that currently have a pending drought declaration. Again, resources will be placed into the chat. As I articulated, as conditions evolve across your respective county or region or state, what happens there matters. And just recently was published was the Water Year 2025 Pacific Northwest Impacts Assessment. The Pacific Northwest Impacts Assessment were gathered in 2 separate but similar annual Water Year recap and outlook meetings focused on Washington, Oregon, and in Idaho. Additionally, the University of Washington Climate Impact Groups and Washington State Climate Office helps to distribute the annual Pacific Northwest Year Impact Survey across the Pacific Northwest. The respective link to the document can be found in the chat. And these assessments are critical in being able to provide a beneficial resource for future management of drought and other extreme events. There will be another impacts assessment here for the coming up in the fall that will be survey and respective meetings will be held to again capture the impacts that we have felt from this specific water year. I know that there's a lot going on across the Pacific Northwest, so if you would like, you're encouraged to stay in touch with NIDIS to sign up for our respective drought early warning system emails, our respective bi-weekly newsletter, or even our tribal news engagement letter as well. Conditions have been rather historic across most of the Pacific Northwest, so please feel free to go ahead and sign up and stay up to date and in touch with NIDIS as conditions evolve across your respective state and the region. So thank you again to all of our speakers who will be presenting today. Please mark your calendars for our next webinar, which will be held on June 22nd. With that, we will transition over to our first speaker, Jacob Genuisi with the Washington State Climate Office. And I want to make a quick note as well that if you do have questions during any of these presentations from our speakers, please go ahead and find little squares in the bottom right-hand corner of your screen. And this will give you an opportunity to enter into Slido and submit your questions real time. And again, we'll try to get to as many questions as we can at the end of our presentations here today. So with that, Jacob, please feel free to take it away.
Thank you so much. I appreciate it. And thanks to everybody for tuning in and talking about drought and taking the time to learn a bit more about conditions this year. I'll be giving a climate recap and current conditions update, talking about winter conditions and sort of where we shook out as far as April 1st and throughout April as well. I'm Jacob Genuisi. I'm an engagement climatologist with the Washington State Climate Office at the University of Washington. Next slide, please. So I'll be starting out with a early winter recap, so looking at October through December of 2025. Then I'll move to a late winter recap for January through March, and then look at current conditions in April 1st snowpack and sort of the how it lays right now. Look at things. Next slide, please. So for early winter, October to December. So starting out the kind of cool season in October, it was a fairly near normal temperature month. 80th warmest on record and 42nd wettest, so pretty near normal as far as temperature and precipitation goes. But then as we moved to November and December, we saw really, really warm conditions region-wide. So these stats are for Washington, Oregon, and Idaho combined, and the record length goes back 131 years. So when we say, second warmest November and warmest on record December, these are really remarkable from this really long record of temperature and precipitation data. As far as precipitation goes, so I mentioned October was sort of near normal, and November was a little drier than normal. And then December, we saw wetter conditions move in. This was associated with some of the flooding we saw in Washington, and just pretty heavy rainfall and persistent rainfall across most of the region, or much of the region. So definitely wet, but those warm temperatures didn't allow for most of this to fall as snow, as we'll see kind of later on in my presentation as well. Next slide. So to look at this spatially across the region, this is showing October through December precipitation anomalies on the left, precipitation rankings rather, and on the right side is mean temperature rankings. And so starting with the left side on precipitation, you can see really that wet December is what's showing up here. We see wetter than normal conditions across much of the region, including across the Cascades in Washington and western Montana, Idaho. We do see some drier than normal conditions across southwest Oregon. So starting off the winter with drier than normal conditions there. And then you can see on the right-hand side in temperature rankings, really above normal temperatures region-wide. This was really persistent throughout the entire winter, and it began all the way back in November into December. Next slide, please. So then moving forward to late winter, so starting in the beginning of the new year in January through March. Next slide. So looking at a similar look at rankings back in that 131-year record length. So starting with January, February, and March, all of them had top 10 warmest temperatures for the month. And this is again all the way across the region, including Washington, Oregon, and Idaho. So very warm conditions persisted not only November and December, but all the way through the rest of the winter. January was also quite dry, and this is important to note, just given that January is a really important snowpack building month for us. It's usually pretty cold, and we can count on reliable precipitation most years, but this year, not only was it warm, but it was also dry. So really not setting us up in a good place as we headed into February and March. And then just to note once again, even though February and March came in kind of near normal precipitation, those warm temperatures meant that anything that fell tended to fall as rain instead of snow, especially at middle and lower elevations across the region. So just really noting that warm temperature anomaly was really persistent throughout most of the season. Next slide, please. And once again, looking at this spatially across the region, this is January through March. And on the left-hand side, just like before, we have precipitation, and on the right-hand side, we have temperature. And so just noting that the drier than normal conditions in January are what's really kind of popping out here in this 3-month period. So you can see that most of Oregon had much below normal precipitation and those darker browns. This also included southern Idaho. You can see the Snake River Plain had below normal precipitation as well. And then just also circling in north central Washington, the Okanogans and Rockies also had some pretty severe precipitation deficits as well. And then if we look at temperature rankings on the right-hand side, once again, those temperature anomalies were present pretty much across the entire region. Record warm temperatures across western Montana and parts of southern and central Idaho, and then much above normal temperatures elsewhere in most areas. Next slide, please. And so kind of putting this together, looking at this full winter period, or I guess cool season period, a little loosely defined here, but October 1st through April 22nd. So this full cool season period. Left-hand side, we're looking at precipitation, showing sort of that similar pattern where above or wetter than normal conditions across the northern tier of the Cascades, western Montana, northern Idaho. And then drier than normal conditions across western Oregon and southern Idaho. These drier than normal conditions across Oregon have been pretty important, and Idaho have been important for their really historic snowpack deficits. On the right-hand side, just once again reiterating how warm this winter's been. It was the second warmest October through March period on record, and we saw about 2 to 6 degrees above normal region-wide. So really, really remarkably warm conditions this winter. Next slide. And so now looking at current conditions. So looking at snowpack as of April 1st, you can see kind of the same story you'll hear a lot of today, right? Snowpack is quite low, especially across Washington, Oregon, and southern Idaho. Those reds indicate areas with less than 50% of normal snowpack, which is in most basins, if not a record, a near record low snowpack. You can see that there's even basins in much of Oregon that are below 10% of normal, same for far southern and southwestern Idaho. Washington fares a little bit better as a percent of normal, so around 50% in some of the Cascades of Washington. And then northern Idaho and kind of western Montana are a bit closer to normal, 75% of normal or above. And there are some small areas, a few basins in western Montana that are near normal, but that's definitely the exception rather than the rule across the region. Next slide, please. So to look at more recent conditions, so now April 1st, we just looked at April 1st snowpack, and now this is conditions, both precipitation and temperature for April 1st through the 20th. And I just wanted to highlight that it's been a pretty dry start to spring here in the Washington Cascades. So definitely seeing those conditions emerge as we head into spring. There were some wetter than normal conditions near the far western Snake River Valley and also eastern Oregon. And you can see that in kind of those blues and greens here on that map on the left. And then temperatures, unfortunately, we've seen these warmer than normal temperatures continue, not only from the winter, but also into spring now. And so we're starting to see a little bit of early season snow melt, and definitely not what we want to see coming off the heels of a low snowpack here. Next slide, please. And so this is a kind of updated look at that map I showed you a couple slides ago, just showing snowpack instead of April 1st. Now we're at April 20th here on this map. And it's kind of hard to see, I should kind of toggle back between, but some of these basins have declined is the kind of main takeaway here from April 1st. So just indicating that snow has begun to melt out across the region, and it's melting a little bit quicker than normal. Also noting that many basins recorded their peak snowpack a bit early this year. Usually we see peak at April 1st, but some basins have started or peaked 2 to 3 weeks earlier and now are melting out more quickly than we'd like to as well. Next slide, please. And we'll look at BC as well. We can see that the southwestern portions of BC, those kind of lower elevation and coastal ranges, are seeing a lot of the same snowpack deficits, mainly due to those warmer than normal conditions across the region. Precipitation has been well above normal in much of BC, though, so those areas in the interior of BC and northern BC where it's been cold enough to support snowfall all season, those have actually seen higher than normal snowpack as we head into the spring. So it's great news for them, and we like to see that. But those southern portions of BC are still are struggling in similar ways that the U.S. side is. Thanks. Next slide. So to look at how snowpack has kind of evolved over the year, this is showing SWE, which is snow water equivalent, so the actual amount of water that's held in the snowpack. And this year is labeled, you can kind of see this black line meandering through this graph, and the shading in the background indicates the kind of historical range of what we like to see. So that sort of light green shading is normal or sort of near normal. Anything in blue is a really good snowpack year, and then anything in yellow and red is a poor snowpack year. So you can see a few previous years plotted here, just showing that this year is in that red shading, which is less snowpack than 90% of years in the historical record. And it's not quite as bad as 2015. You'll see plotted in that kind of bluish turquoise line. That was our record lowest snowpack year, but we're not far off either. So we're not as bad, but we're pretty close to it. Next slide. And just wanted to walk through here, just kind of state by state, a kind of quick look. You don't necessarily have to look exactly at these graphs closely, but just showing here that really every state is below normal snowpack. So Washington here, you can see that we're in that red shading and actually doing a bit better than the other states so far. But Montana, Oregon, and Idaho are all kind of meandering back and forth between record low or near record low pretty much all winter and as we head into the spring as well. And I included those percentiles as well. So 5th percentile in Washington, 9th percentile in Montana, 2nd percentile in Oregon, and 2nd percentile in Idaho as well. And just noting, as Jason noted before, 3 of these states have issued emergency drought declarations. Washington and Idaho have issued statewide drought declarations, and Oregon has issued declarations for 9 counties. Next slide. So just pointing out water storage, an update on the Yakima Basin water storage. On this graph here, this is total storage capacity across the entire basin. The blue line is current water storage for the current year. The dotted red line is average storage, and then the green dashed line is last year's storage. And you can see this blue line is bumping up against the total storage capacity of the basin, meaning that reservoirs are almost completely full thanks to lots of rainfall this winter and some December flooding events that have really boosted storage. But crucially, that also means that we can't collect as much of snowmelt, especially if it happens really quickly this spring. We won't be able to collect as much as we'd like to. So this lack of remaining capacity is really kind of limits our ability to capture the water that we need to when we need to. Next slide. And to illustrate this a little more, just why snowpack is so important and critical to water supply, this pie chart is also for the Yakima Basin. And that piece that we just talked about, that reservoir storage, is shown in this light blue pie slice kind of in the bottom. So this is what we get from storage from winter rainfall or any runoff during wintertime melt events. And this darker blue pie is what is currently forecasted for the April to September water supply. So this is the water that will come from snowmelt up in the mountains that will make its way into reservoirs. And then this other missing piece of the pie, this is the rest of the demand that is projected to be unmet this year. So just showing that, the reservoirs, even though they're near full in Washington, that only accounts for about 1/3 of the total demand. And that snowpack really needs to make up that 2/3 of this pie. Next slide. And showing an update for Oregon as well. Pretty similar story here. Reservoirs look fine on paper. They're about near median in most areas. They're where we like to see them on a normal year. But given that we have really extremely low snowpack in Oregon, and given those dry winter anomalies, especially in Southwest Oregon, we're expecting demand to come in pretty intensely in the early season, so expecting some rapid declines in reservoir storage due to those precipitation deficits, and not much inflows from that lack of snowpack as well. Next slide, please. It's just a recap with some kind of high-level key messages here. So statewide drought emergencies have been declared in at least parts of 3 states, and the principal cause here is record or near record low snowpack. So really looking at that water supply angle when we talk about drought. Also noting that multi-year drought has been present in parts of Washington, looking at 4 years of drought in the Yakima Basin. So those pressures are not just from this year, but multiple years of tough conditions. And despite near to above normal precipitation in parts of the region, warm temperatures are really the main cause for most spots this year, especially Washington, Idaho, and Montana, and southwestern BC. Those precipitation deficits in Oregon also further limited snowpack growth. And the only exceptions to our snowpack problem here is in west central Montana, where those few basins have near normal snowpack. And then reservoirs are in decent shape, but once again, reservoirs alone are not enough to meet demand, and snowpack is really that crucial piece of water supply in the summer for our region. So really going to be watching how the snow melts out, and hopefully we can have a nice, slow, gentle melt out this season.
Great. Great. Thank you so much, Jacob, for that presentation. Remember, happy to take questions here at the end. And yeah, thank you again, Jacob, and we'll transition now over to Henry.
All right, thank you, Jason and Jacob. Yeah, my name is Henry Pye. I work at the Northwest River Forecast Center. I'm sorry, hopefully everybody hear me okay. Yeah, go ahead and go to the next slide. All right, great. Yeah, next slide. And so, yeah, just some key main takeaways up front here. As Jacob's been describing, despite maybe near normal precipitation in certain parts of our area, that persistent warmer than normal temperatures have led to poor snowpack conditions, particularly in the U.S. portion of the Pacific Northwest. The second bullet there, while water year to date observed runoff, which we'll be looking at later on, remains pretty elevated for the water year so far, the remaining season, water year streamflow forecast largely remain below normal, except for some main stems of the Columbia. And then outlooks, longer term outlooks remain dry with some El Nino predicted for next fall. Next slide. All right, so hopefully I could cover this quickly, as Jacob had a great summary of what's happened so far. So just some quick snapshots on the top row. On the top left is seasonal precipitation for the water year so far, for where light green there is indicating near normal conditions, and then dark green and dark blue indicating wetter than normal conditions, and then the warmer colors indicating drier conditions. Our weird polygons there are watershed basins, and yeah, just highlighting, what we've seen before, where Oregon has and central Washington east of the Cascades in the northern part there are seeing precipitation deficits, but otherwise pretty normal or above normal in a lot of places. But the story of most of the water year so far has been this drier than normal temperature signal that is depicted in the top center graph. It's accumulated temperature departure for the same basins. You see only warm colors there, all indicating warmer than normal temperatures. And in the top right, we have Snowpack. I believe we were looking at basins in Jacob's presentation. Now we have kind of the individual snow pillows combined from NRCS, BC Hydro, and Alberta Environment and Parks. And so again, yeah, pretty bleak story due to some of those warm temperatures, where essentially Oregon, if you see there, has a lot of white dots indicating snow pillows have already melted out. And yeah, in terms of current conditions, the warmer colors indicate lower than normal snowpack, and then the cooler colors indicate larger than normal snowpack. And so yeah, pretty big deficits, particularly on the US side. There are some near or slightly above normal, but those are probably at the higher elevations. And then finally, Canada's looking pretty swole for the most part. And so the bottom center graph there is a hypsometric SWE plot. This is using the no-risk gridded snow product. And so we kind of have the area above the Dows highlighted in the bottom left corner there, the domain that flows into there, that watershed boundary. And so for a hypsometric SWE plot, the y-axis is elevation and the x-axis is volume. This denoted in million acre feet, and these are 100-meter elevation bands. And so I just wanted to highlight the current water year is in blue. The April 1st value is in dashed yellow, and then the median climatology is the gray line in the back in that bottom center plot. So just wanted to, whenever you have that blue, usually I compare a lot of things with that median line. And so what you can kind of see is that both the blue and dashed yellow are to the left of that gray line, indicating lower snowpack volume during this snapshot time of year. And so yeah, and then just wanted to show the April 1st to the current water year, showing that lower elevations have kind of ripped off a little bit more. And then the final bottom right plot is just kind of the percent normal per elevation band. And then again, you see at 6,000 feet, that percentile value start to drop fairly lower than normal, even reaching down to 50% once we get to the 4,000 feet-ish elevation graphic. And so yeah, that plot was inspired by University of Montana. They have their own, a lot of great products there. So go ahead, next slide. And yeah, a little bit about the water year progression and stream flow to date. In the top left is accumulated graphic for the precipitation. So we've been looking at snapshots. So this top left is a little bit more of a time series. The x-axis starts at the beginning of the water year. The y-axis is the accumulated precipitation. You kind of see the progression as we go, where the December events that hit Washington, Oregon, much of our domain, you see it bump above the average dashed line there, where, sorry, I forgot to mention that blue line is our current water year accumulation. And then those two other solid lines are kind of the prior to water years accumulation. So as of right now, we're actually riding at 106% of normal. And then again, we had the same snowpack plot that Jacob presented earlier. So presenting the early SWE. I just wanted to say that I believe no Canadian station data is included in that graphic. And then on the top right, there is a snow covered area product produced by the National Snow and Ice Data Center. I believe their satellite product also truncates off part of the northern part of British Columbia. But if you see, at least in January, we were at a record low snow cover there in the blue line, which is below all the gray areas and all the other lines that indicate kind of the range of snow covered area. And then at least we're within some ranges there as of, I believe, Fridays when I took the snapshot. So yeah, that blue line indicating the water year so far. And now in the bottom center plot is the Columbia River at the Dalles, the daily stream flow value from the USGS. And we have kind of the historical ranges. Just keep in mind the USGS has a fairly large normal range where the whole inner quartile or inner 50% of the stream flow values there are indicated in the kind of the lightly shaded gray indicating normal conditions. And the black line is our water year to date. And then the dashed blue line is the last water year, which had a pretty low snowpack in general. So we do kind of see some of those increases in stream flow from that December event and some precipitation and early melt in March. And now the real question is whether we are starting to see early melt as we see the kind of rise in that black line for probably the past week or so. And then finally, when you sum this all up in the bottom right, there's the product produced by the Northwest River Forecast Center, our observed runoff to date. Just keep in mind that our observed and seasonal water supply forecast are naturalized, so they try to remove the impacts of reservoirs. And so, yeah, but describing the plot in the bottom right now is, as with most of the plots, light green is near normal. The cooler colors indicate larger than normal flows accumulated as a volume, and then the warmer colors indicate drier than normal flows. And so for the water year so far, you see the northern part of our basin is very much in the kind of the dark blue area, particularly in Washington, northern Idaho, western Montana, due to those two events that we were talking about and earlier the normal snowmelt, while Oregon and southwest or South Idaho there have been seeing some deficits despite the potential for early meltout. Next slide. And so again, a little bit bigger picture than what Jacob was looking at. This is a snapshot from the U.S. Bureau of Reclamation. They have some of their major projects listed in this map. They also have the current drought layer over those overlaid. So the two reservoirs kind of highlighted in the teacup diagram is Grand Coulee and Hungry Horse, both fairly large projects denoted there, and they're riding well above normal, likely due to some of this earlier than normal snowpack melting. And then the rest of the reservoirs, I believe they're probably pretty close to normal. I believe American Falls in the upper Snake area is the lowest value that I saw. I think it's riding at 87% of normal the last I checked. Next slide. And now getting into actual water supply forecasts. Typically, we have a hydrologic model, we have a snow and a soil model, and that routes eventually to stream flow that we use for both flood forecasting and our water supply forecasts. So typically, we take 10 days of precipitation forecast, and we use it in our ensemble stream flow prediction. So after those 10 days, we actually add historical, all that is required in our model is precipitation and temperature. And then after those 10 days, we have ensemble pairs of historic precipitation and temperature pairs that drive our hydrologic model after those 10 days. And so we call that our ensemble streamflow prediction, or ESP10 product, which we'll go over later. But just want to highlight for the next 10 days, as of, I believe, a snapshot from yesterday, the left-hand side is the accumulated 10-day QPF. And typically I look for the red category, which it is not present. So that usually indicates a precipitation value of 2 inches or above. That center graphic is our QPF related to percent of climatology. All of it's in red, indicating drier than normal conditions, at least for the next 10 days. And then in the top right, far right, I have a small inset for what we typically see this time of year for the next 10 days. So and then highlighting the QPF sources at the bottom there. Next slide, please. And now finally getting to our water supply forecast. Again, keep in mind, these are try to be naturalized flows, so trying to remove the impacts of the reservoir operators. And so just wanted to highlight the difference of this map versus that the observed stream flow map that we were looking at before, where we had Washington, northern Idaho, and western Montana all in the well above normal. But now with the lack of snowpack, as Jacob has mentioned, our natural reservoir, our remaining seasonal water supply forecast, which is denoted as April through September. So we do have about a month's worth of observations in this forecast, are showing well below normal for most of Washington, most of Idaho. Some headwaters maybe in the Montana area are still looking near normal, and Oregon is also looking very, very dry. And then the one bright spot there is in Canada, where they're above normal snowpack is really buoying up the Columbia main stem there. And so essentially we like to split out a lot of things in our water supply world in the Pacific Northwest for areas above Grand Coulee, highlighted in the dark blue circle there, and then in the Snake River Basin, highlighted in the red circle. And then I have on the right-hand side monthly forecasts volumes for the remaining set part of the water year. So the graphic again is time series, where the x-axis is time, and then the y-axis is in volume, typically expressed in 1,000 acre feet. And all the plots here, the box and whiskers are essentially are populated by those ensembles I was talking to you all about before. Those blue bars are the observed runoff to date, and those green dots are the 30-year normals. So for the top right plot, you see in the upper Columbia or above Grand Coulee, the box is encompassing the interquartile range is essentially encompassing the green dot for much of the remainder of the water year. But once we move down south to the Snake, we see that even the whisker, the 10% exceedance probability is not being met for essentially the months of May and June, and it's looking pretty bleak down there. And then finally, when you sum that up, the Dows, we kind of have the whiskers kind of encompassing the green dots for the month of May and June before the box, the green dots we start to go back to pretty normal flows probably by the end of summer. Next slide. And so just, quick recap. Probably don't have to go over this too much. Essentially, a lot of the dynamics now are really being driven by the snowpack in the top right, and our April through September forecast in the bottom. That we usually try to figure out what is the driving thing for a lot of our seasonal water supply forecasts, and snowpack is kind of the big driver there, where it shows kind of the biggest correlation between color schemes there. Next slide. And looking a little bit further out, these products are not included in our water supply outlooks or forecasts. So typically, once it becomes out of a forecast range, we call them outlooks. And I don't want to take over Michelle's thunder too much, but essentially what I interpret this as, these are probabilistic guidances on the left-hand side for the next 3 months for seasonal temperature and precip, essentially a higher probability of both warmer and drier conditions. And unfortunately, particularly on the interior portion of our basin east of the Cascades. And then for the probabilistic ENSO guidance, I have that plotted on there, where we do have high probability of El Nino occurring. And then on our website, we do have, for water supply purposes, we have a pretty loose correlation there in the bottom right-hand plot. I know Larry out at Oregon State has mentioned, though, for very strong El Nino signals, and you could see, and that's on the far right, that scatter plot does have above normal historical runoff conditions for some of those very strong signals. Next slide. And finally, wildfire potential outlook. These are obviously a big concern, especially for our WFO office that we share for across the hallway. I didn't see anything for the month of May, but I did see things start to pop up for the month of June, which is plotted on the left-hand side, and July on the right-hand side. And it's really starts to pick up on the interior initially, and then it kind of spreads to the southern portion of our basin, and then a little bit into northern Idaho there. And next slide. And I think that is the main takeaway. And we do have, and a shameless plug for our next water supply brief will be coming up here shortly. So if y'all are concerned a little bit more with a little bit more water focus on that one. So
Great. Thank you so much, Henry, for that presentation. And now we will transition over to Michelle. Feel free to take it away. Thank you.
All right, thanks so much. I really appreciate the invitation to present. I am the ENSO team lead at the NOAA Climate Prediction Center. I do not operate alone. I have this wonderful ENSO team. Those names of folks you see at the bottom, they're really the minds behind the ENSO outlooks that get updated every month. This is a combined decades and decades of ENSO prediction experience and a lot of knowledge about the ocean and the atmosphere and the dynamics that connects them. So I always think that this is one of the leading ENSO products in the world, and it really is due to this team. So what is going on with ENSO? That's why you are all here, I'm sure. There is an animation there, and that is showing the sea surface temperature anomalies for different weeks. And it starts this loop roughly in about mid-January, and it goes to the last week. And what you'll see when you focus, especially on that region that defined by the box, the Niño 3.4 region, we started the period fairly cool. And that was evidence of our La Niña. And then more recently, at least, and especially over the last couple months, we've seen this gradual trend back to ENSO neutral. Now, I recognize that not everyone knows our various ins and outs of our ENSO definition. Unfortunately, I don't have a whole ton of time to get into the particulars, but in general, when we historically say that there was an El Nino, we look at this region, the Niño 3.4 region, and we evaluate whether it's above a threshold of 0.5 degrees Celsius in this region. And we also want it to persist. We don't want a week or two or a month or two of El Nino conditions. We want it to persist for a number of seasons. So historically, when we look back, we want at least 5 overlapping seasons. We want this thing to have some longevity. And usually it does, because the El Nino system is what we call coupled, which means there's a strong interplay between what's happening at the ocean surface and the atmospheric circulation, winds, pressure, rainfall right above it. And we want to evaluate both whether the ocean and atmosphere are consistent with El Nino. So where are we right now? Next slide. So this is the update as of the 9th of April, and we do this monthly, second Thursday of every month, and there's a link there at the bottom. And when we updated this earlier this month, we said we were in El Nino watch, and this was the second month in a row we've had El Nino watch conditions. And what that means is that conditions are favorable for the development of El Nino within the next 6 months. Our synopsis statement observed that we're currently in ENSO neutral. Neutral means neither El Nino or La Nina. And those are favored through the April, May, June season. That's an 80% chance. Starting in the May, June, July season, El Nino is likely to emerge about 61% and then persist through the end of 2026. Next slide. So this basically articulates in graph form what I just shared. So the MJJ is that May, June, July season I referred to earlier. And again, that red bar is showing about 61%. There's also gray bars there that's neutral. And so that means neither El Nino or La Nina is present. But what you see fairly dramatically is these red bars increase as you go into the fall and winter. In fact, they top out about 90% chance. This is a fairly confident forecast. And so, as you can imagine, this and also other related model guidance that's being put out on the web has elicited a wide variety of reactions. Next slide. And needless to say, some of these reactions are a little bit more reasonable than other reactions. First, I want to say that Super El Nino is not a NOAA or Weather Service term or definition. I remember seeing online someone respond to an article where they were highlighting Super El Nino about how scary it seemed, and that's really not a great reaction. That's as the El Nino team lead, I think that's a little going too far. So I really would discourage the use of super. We are certainly aware of the possibility of a high-end El Nino historically, and I'll discuss that in the coming slides. But this is not a monster. It's not going to destroy anyone's house directly, and I'm going to talk a little bit more about what El Nino means. And then you have, of course, the reaction on the right-hand side, which is a little bit more bucolic, where you have a gardener considering what kind of flowers they're going to plant based on the shift in the odds of El Nino. All right, next slide. So this will happen at least once this winter. There are no El Nino storms. The minute it starts raining in California, there's always a headline saying El Nino storms are here. And that's just wrong. That's not how El Nino works. What El Nino does is by shifting the patterns of rainfall and along the tropics, is it shifts the jet stream and the circulation over the Pacific and North America's sector. It's these pattern of so-called teleconnections, and you can read more about teleconnections, that link at the bottom. And you can think of it as essentially a highway that shifts weather patterns in more preferred directions. And during El Nino, what you tend to have is at mid-levels in our atmosphere, lower than average pressure over the North Pacific Ocean. And you have this kind of ripple effect, this big wave train over North America, where you have basically trough ridge and trough over the southeast. And the jet tends to be southward and eastward extended. And so weather events tend to operate along these preferred paths. But it's important to keep in mind that if it's rainy or if it's drier, those extremes can be made more likely by El Nino, but El Nino likely cannot be attributed to that event, at least solely by itself. Usually there's always some interplay between weather, random weather features that we can't predict far in advance, and also other climate patterns and trends can play big roles in modulating the likelihood of these events. Next slide. Another thing to keep in mind is that we are really at the very start of a possible developing El Nino, okay? Last month, we ended our La Niña. It was the first month of ENSO neutral conditions. So when you look at the evolution of temperatures in that Niño 3.4 region, if you remember my animation at the beginning, so we measure sea surface temperature anomalies, and each line there is a different anomaly in that region. And they're color coded by strengths, but each year is basically a different line. So you can see all the El Niños going back to 1950. The red line, the kind of the darker red line, is the last El Nino that we had. Right now, the black line is our current evolution. It's actually mirroring the 2023-24 event pretty closely. But there's a long way to go. And what you'll also notice is none of these lines lie perfectly on top of each other. So this evolution will be distinct in some way going forward. And we could also see some surprises. We may see something like ENSO neutral next winter. It would be kind of wild to see that, given the probability is only 10%, but that's certainly in the cards as well. And so we have a long way to go before these sea surface temperatures tend to maximize during the Northern Hemisphere winter. Next slide. So yeah, this was already shown in the previous slide. This is a new graphic. We've actually been calculating these probabilities for a number of years, about 5 years now. However, they were buried in a table. I'm not sure how much uptake there was getting, and we were also just, quite frankly, getting inundated with questions about strength. So went to the drawing board, consulted some folks, and came up with this graphic. And so this shows essentially the bars are the same as the earlier graphic I showed you, except now there's probabilities of different intensities embedded within here. And so they vary by season. If you go to the October, November, December, November, December, January, those two right bars there, basically there's almost equal probabilities between very strong, strong, and moderate. They each have about 25% chance. And then the leftovers, that final 25%. So there's about a 1 in 2 chance of at least a strong event. There's a 1 in 2 chance of it not making the strong or very strong category. There is a 1 in 4 chance of a very strong event, and that's usually what people are referring to when they're talking about super. And then, of course, we can't rule out the possibility, slim, that there will be ENSO neutral, and that's that gray bar. And the other thing is there's a disclaimer here in the bottom right that's part of this figure. It's really important, and this has always been my hesitation about talking about strength information, is that a lot of people assume a stronger event means you get literally bigger impacts. So if you're supposed to get rainier during El Nino, that means the rain will be even harder. And that's just wrong. That's not how it works at all. All a stronger El Nino means is that it can make it more likely that that certain impacts will occur, but it doesn't ever guarantee them. Next slide. So why is there this high confidence in El Nino? Well, we're looking at multi-model guidance. You may have seen online a lot of people emphasizing what I call single models, ECMWF and others. I discourage that. I don't think it's a good idea to consider single models. There isn't one great model. This isn't like the Euro is always the best model. It's not. It's not always the best model. It could be in this case, but it's not consistently so. So we use multi-model guidance, particularly the North American Multi-Model Ensemble. So you're seeing a plume of different outcomes. And basically most of these lines, as you get into the fall and upcoming winter, are above our El Nino threshold. It's a little hard to see, but it's that red dash line. There's also a black dash line. That's the strong El Nino threshold. And actually most models are above that threshold as well. So the model guidance, even though this is April and we're very early in the possible evolution of El Nino, is fairly bullish. And this is something you have to pay attention to because it tends to be the stronger events form earlier in the year and tend to show their hands early. So we think there's reason to believe that there is this possibility. Next slide. The other thing is we're looking at the subsurface ocean here, and this is essentially almost a precursor, not 6 months in advance precursor, but 1 to 2 months in advance precursor is the growth of the above average temperatures below the surface in the equatorial Pacific. I always liken this to the fuel for the development of El Nino. So it's kind of like, getting the gas in the car ready for a long trip. And so this is, we're seeing that gas being kind of filled up here. And these are significant anomalies at the subsurface. Does that mean we're going to instantly see that at the surface? No, that's not how the subsurface to surface connection works. Dynamics are a little bit more complicated than that, but there is definitely room for growth here and warming at the surface. Next slide. The other thing we're seeing is an increase in westerly wind anomalies across the equatorial Pacific Ocean. This is showing time evolution of the zonal wind anomalies, and it's just showing the equatorial Pacific. And basically those reds are westerly wind anomalies. And when you get westerly wind anomalies, they help warm the ocean surface. So we're seeing, we've seen some since March, fairly strong event in early April. And we're also seeing those westerly winds expand across the equatorial Pacific. Click again. However, it's important to keep in mind these westerly wind anomalies have to persist and continue, and there's no guarantee that they will. This is the most uncertain part of our forecast because these wind anomalies in tropical Pacific can be forecasted pretty well 7-10 days in advance. Other than that, we kind of have to just hope the ocean and the atmosphere couple and start working together, and that helps grow the events. It's the feedback or interplay between the ocean and the atmosphere that gets these El Niños going to help sustain them. And there is some uncertainty here. On the right is another strong El Nino event, a very strong one, in fact. And what you see is that over the course of that entire year, showing the entire calendar year from January to December, we had those westerly wind events occur and reoccur and really lock in and couple. There are times like in 2014 where the westerly wind events got going in the spring, and then by summer it had kind of faded out. So that's certainly a possible outcome here. Next slide. So I know I'm going to shift quickly to impacts and then we'll wrap up. There is a natural tendency to summarize information. This is the typical winter El Nino pattern over the United States. It shows the jet stream. It's extended and southward shifted, wetter over the southern tier. And while this gives you a good idea of like general basic impacts associated with El Nino, it's important to keep in mind, next slide, that there can be a lot of differences between strong and very strong El Nino. So this is what I call the expected El Nino precipitation pattern. Essentially, you have drier conditions over the Cascades, and then also over the Northern Rockies, and then a little bit of wetness there in Southwest Oregon. And so this is a general kind of conventional El Nino-like pattern. But if you actually break down and look at every single strong to very strong El Nino going back to 1950, it looks more like this. Next, go ahead and click again. All right, so this is the different strong and very strong. And what you see is, yes, there's a general tendency toward drier conditions that match the expected pattern, which sits there in the middle, but not, all these events are a little distinct. And certainly some of the bigger ones like 82, 83, and 97, 98, and 2015, 16 on the left there were actually quite wet, particularly in the western part of the region. Next slide. And so it's important to keep in mind that seasonal outlooks are expressed as probabilities. They're provided in % chance of an outcome. That's because no impact, even during a very strong or whatever you want to call it, El Nino, there is still going to be these probabilities. El Nino does not ensure anything. So you generally see an El Nino-like pattern across the entire country, both in precipitation and temperature. This is for the upcoming winter. This will update on the third Thursday of every month. So these maps will shift. And as you get closer to the event, they may become more confident in certain regions. Next slide. All right, it's important to keep in mind that our El Nino probabilities are not the same probability impacts. Here's an example from November 2023 where we had a 100% chance of El Nino. Next. But the impacts, of course, were much less. So there's 3 categories, 3 possible outcomes: above, median, and below, or sorry, actually equal chances, which just means there's climatological toss-up. But anyway, the point is these probabilities are not the same as the chance for El Nino itself. Next slide. And so that wraps us up. We're currently neutral. We do expect a possible formation El Nino May, June, July, and with fairly high confidence in it persisting through the end of 2026. It's due to these fairly aggressive seasonal prediction models and recent observations. Keep in mind, there's still a 1 in 10 chance of El Nino not forming at all. I know that seems a little silly for me to highlight, but people do treat it like it's 0, and they shouldn't. Remember, people have different decision thresholds. For example, if you told me there's a 1 in 10 chance of that building collapsing, would you go into that building? And I would say no, absolutely not. So in that case, my decision threshold was high enough, or rather low enough, that I would still avoid making that decision. So keep in mind that there is a range of outcomes here. The only confident thing we can say is there probably won't be a La Nina. And then, of course, keep in mind that there's a 50% chance of a strong or very strong, a 50% chance that might not be. The impacts will have uncertainty, and those uncertainties are expressed as probabilities. And that will go ahead and wrap things up from my end. Thanks so much.
Great. Hey, thank you, Michelle. That was such a great presentation and really helped contextualize and so into conditions and what may or may not occur moving into the summer and winter months of 2026.
Thank you.
That puts us right at the top of the hour. I wanted to say thank you again for all of our speakers, Henry at the Northwest River Forecast Center, and Jacob at the Washington State Climate Office, and Michelle with NOAA's Climate Prediction Center, excuse me. So again, thank you all for attending and listening into today's presentations. And we look forward to seeing you next time at the next PNW DEW's Climate Outlook webinar on June 22nd. Thank you and have a wonderful day.